Hi class, welcome to part 3 of your two-way ANOVA assignment. So moving on to task 3, this is where we left off, where we had collapsed our data. So we had 100 participants from North America, 100 from Europe, and 100 from Asia. And we saw that we had a significant main effect here of region. And then following up with some t-tests, we found out where those significant differences were, and it seemed as though North America was lagging behind Europe and Asia, which seemed to be going neck and neck as far as weekly pedometer steps. Okay, make sure you include captions on your assignment. All right, so the last thing that we are going to do for our assignment, task 3, is to demonstrate or create a frequency distribution of your data. And so I'm just going to do this very quickly since we have a few tutorials and you've had a lot of experience with frequency distribution. I'm just going to move this and I'm going to show you what I've done just for demonstration's sake. I've created, so here's my collapse data, right? 100 participants, region 1, 2, and 3. And I've gone ahead and just selected 50 participants per each group. And so most likely this is probably 50 male participants from region 1, from region 2, and region 3. So this is most likely all male participants here. And this was just to make a point. This wasn't necessarily just selecting males over females for any reason. It's just wanted to see what happens when you half the data. So I've gone ahead and created, here are my bins. So I started with 95,000 and went down by 5,000 increments, or increments of 5,000, all the way down to 25,000 steps. Okay, so I've made this table here. Right, and then of course the frequency formula, let me just move this for just a second, just in case we forgot. So okay, so your data array, so you'll select, your first 50 rows, and then our first 50 rows for region 1, and then your bins here. You'll reference these bins here. Okay, and those are the same bins that you're going to use on your graph. So I'll just do this. So from region 1, that would help. My bins, and actually that should cover it. Okay. So there's a formula for frequency, just in case you forgot. Get rid of that. All right, so what happened when I graphed this? All I did was essentially the same technique I used before, where I highlighted this, my table here, and okay. So looking at my N of 150, you can see that it's relatively normal, but again, it's not that perfect bell shape, and I probably could have played around with the axes a little bit, got it a little bit more normal. But you can see when compared to the N of 300, how much more that looks like that nice bell shape curve. Okay. So again, just by being able to collapse the data, we're able to get an even more, we're able to increase our sample size, which then of course gives you a more normal distribution. It also gives you a little less variability between, between population, or between your sample, so that there's not a great spread. Right? So there's ways to do this mathematically, looking at formulas for skewedness and kurtosis, but I think of visuals I think a visual is nice. Right. So what I would like you to do is create a frequency distribution using your new data set, okay, your collapsed data set. If, just a side note, if the p-value for sex was very close to 0.05, if it was approaching significance, which is not significant, but if it was approaching significant, say it had been a 0.051, it might not be a good idea to collapse the data. But in our case, the p-value was a 0.1. So, and we can see there was an advantage to that. So, and certainly our graph, when we looked at, the three countries here, I guess, or continents, it really does tell a nice story. And if we kind of muddied this up with males and females, it might not have really gotten the point across that, North America is severely lacking. Right. So just keep that in mind. So again, going back to your frequency, I don't want you to have to get too hung up on this. I'm going to just move this one. I started with a bin of 95,000 steps in 5,000 step increments to 25,000 or minus 5,000 step increments. Okay. All right, that is it. That is your assignment in a nutshell. If you have any questions, of course, contact me. But happy excelling.